Let me introduce one more piece of notation. Z effective equals Z, which is the actual nuclear charge, minus S, where S stands for shielding or screening. I think these words are used interchangeably, but I'll try to use the word shielding. Okay. Shielding is when the electron is in the interior. When the electron is in the interior, according to Gauss's law, it's as if it's where? Put it in chat. If the electron is in the interior of a spherical distribution, it's as if it's at the nucleus. Okay, so now look at 1s. Does 1s sit inside 2s and 2p? And the answer is it does sit inside. There it is. The average distance for 1s is here, and the average distance for 2s and 2p are here. So 1s sits inside the 2p, and therefore, according to Gauss's law, it shields. If there's an electron in 1s, and there are electrons in 1s, the electrons in 1s act as if they are at the nucleus, and so the 1s electron makes Z effective bigger or smaller for 2s or 2p. Put it in chat. Does the 1s electron make the Z effective bigger or smaller for 2s and 2p? And the answer is, put it in chat, the 1s electron makes Z effective smaller for 2s and 2p because according to Gauss's law, the 1s electron sits on the inside. There you see it in the distribution functions on the inside, and therefore it's as if it's at the nucleus, canceling this. It's a minus charge canceling out the nuclear protons. And here is the crux. Look at this region right here. I put it in yellow. Look at this region right here. Do you see in that region right there that which electron actually sits inside the 1s electron, closer to the nucleus than the 1s electron? Which of the two, 2s or 2p, has part of its electron density inside the 1s? Put it in chat. And the answer is 2s. When the 2s electron is located here, it is not shielded by 1s. Therefore, is the shielding for 2s bigger or smaller because of this fact that the first bump in 2s is inside? 2s electron has less or more shielding because it sits part of it inside the 1s. It has less shielding. Less shielding means that S is smaller. When S is smaller, Z effective is Z minus S. Z effective is, put it in chat, bigger or smaller? It is bigger. When S is smaller, this goes down. That's a minus sign. This one goes up. And therefore, that's the Aufbau principle. Z effective for 2s is a bigger number than Z effective for 2p because the very first peak the very first peak of 2s is inside the 1s, and there's a name for that, and that name is penetration. The first peak, the first lobe in 2s has penetrated 1s and is responsible, therefore, for the larger Z effective. I'm pretty sure you want to hear that clip over again. I am going to give you a last clip if there is time, where I'll just tell you some stories.